Okay, we're back. All right, so I just did the first 20 problems, and I'm going to do maybe 20 more, and I'll keep doing that until I get to the end of it. And the more time and effort you put into this, the better. All right, so I'm looking at this, and they want me to solve for x. I'm going to write this. This is a Math 119 question. And this is 2/3 to the x. And what I'm going to do is I'm going to write the other side as if it were 2/3 to some power. I'm hoping I can do that. Otherwise, I got to resort to using logs, which I don't want to do. And I'm looking at that, and I just don't see it, all right? So what I'm going to do over here, I'm going to look at the 81/16, and I start to realize it's got to be a negative power now. Let me write this down for you. So 81/16, this is going to be 3 to the 4th power, and that's going to be 2 to the 4th power. So I'm going to say minus 4. Now, if I do that, what do I get? I actually get 3 to the 4th power over 2 to the 4th power, which is what I wanted to get, all right? That's what I wanted to get. Right, let me erase this over here, and I think I'm ready. And what I mean by I think I'm ready, I'm looking at this over here, and what does x have to be? X has to be minus 4. All right, let's do the next one. This one's a domain problem. So I got two roots, and the first root I have is 4 minus x, right? That has to be greater than or equal to 0. I'll write this down for you. This is a linear inequality. It's very simple to solve. I'll put a number line down, and I'm going to visualize what it looks like to me. What does it look like? Well, it's equal to 4. I know that much. And what else is it? Well, looking at it, x is less than or equal to 4, which means it's over here. So I got the domain of that visualized. Now I got the other one to work on. The other one's going to be x squared minus 1 is greater than or equal to 0. And this is also fairly easy to visualize with the material that you learned in Math 119. It's quadratic inequality. X plus 1, x minus 1, greater than or equal to 0. So I'm going to put a number line down, and I'm going to put the plus or minus 1 down. And plus or minus 1 looks like this over here. Minus 1 and plus 1. Now someone says, do I need to put a number line down? I don't know. I need to put it down to look at it. What do I know about this thing? It could equal to the minus 1. It could equal to plus 1. I'm looking at this inequality over here. And then I got to take some test values, and certainly if I thought about it, I'm going to say, if I took a number between minus 1 and 1 like 0, and I plug it in, it would be negative number, so I don't want that. If I take a number after 1 like 2 and plug it in, it would turn out to be a positive number. So I know that's good. And if I take a number below minus 1, like minus 2 and plugged it in, it would also be a positive number. Now what I'm trying to do is find out where these two sets intersect, and they intersect from minus infinity up to and including minus 1. Union, they start intersecting again from 1 up to 4. And this is a combination of two functions, by the way, and I'm taking the intersection of their domains. What's the answer? The answer is staring straight at us, all right? Let's put this one down. This one says calculate directly without using a calculator. I realize some students says, well, if I had a calculator, I could probably do that. A lot of students would still struggle with this, and we're not asking you to struggle with anything. I'm going to use the rules of logs, by the way. And what do you get over here? Log base 25. And this is a sum, so what I'm going to do, the product of their arguments, which is 30 times 1/6. And lo and behold, this is log base 25, and 30 times 1/6 is just the number 5. And I'm going to say, I don't know what that number is, but they want me to come up with it. How would I rewrite this as an exponential? 5 is equal to 25 to the x power. Well, now I know what x is. X has to be 1/2. And why is that? 1/2 represents the square root of 25, and the square root of 25 is 5. So x equals 1/2. Let's look at the k. Got this over here, and they do put some work down for me. This one says find the equation of the line that passes through that point and perpendicular to this line over here. This is a Math 100 question now. How do I do that? Well, I got to get the slope of this line over here. So I'm going to put down slope of this line over here. Well, it's nice if you can do that, and I'll write this down for you. This looks like 2x, 4y plus 5, and then 2x minus 5 equals 4y. And then I'd say y equals, well, I'm dividing by 4, so 1/2 of an x minus 5/4. So the slope of this line over here is just 1/2. Now, what's the slope of a line that's perpendicular to that one? It's the negative reciprocal, so minus 2. So let's write this down. And I write this form over here. Y minus y1, there's going to be y plus 5, equals the slope, which is minus 2, and then x minus 2, which is the x coordinate. And that's fine. A lot of students want to rewrite that, and there's nothing wrong with that, but I am seeing that in the answer key. If you do want to rewrite this, please do so. This would be y plus 5 equals minus 2x plus 4. And what would you get over here? Y equals minus 2x. If you subtract 5 from both sides, you get minus 1. If you want to do that, you can. You don't need to. This is a fine looking answer as far as I'm concerned. All right, this is number 25. And what they say, find the zeros. That tends to be quite easy to do, by the way. And what do you do when you're setting the function equal to 0? By the way, this is math 119 now. And what do you get? I'm going to factor it. And you get x times x squared. Let's see, minus 1. I'm going to continue to factor it, and you get x plus 1, x minus 1. So I got 3 zeros. The 3 zeros are as follows. X equals 0, x equals minus 1, and x equals 1. And they're listed right over here for you. The next question they ask you is an odd function. So someone says, I don't remember that. That's math 119 still. What's an odd function? Does f of x equal minus f of minus x? I don't know. Let's take a look. So what do you get over here? X cubed minus x. That was simple. And this is going to be minus f of minus x. What do you cube? When you cube minus x, what do you get? You get x cubed. I'm sorry, you get minus x cubed. I'm sorry. And minus of minus x is going to be plus x. Now, granted, someone said, I have no idea what I'm doing now. You're simplifying. That's all you're doing. And what does this give you? This gives you x cubed minus x. So the answer is yes. Yes, I got it. All right? The terminals, the intervals where f is positive. Well, that's pretty simple, and I'll tell you why. It's basically sign analysis. How do we do sign analysis? A list of zeros. And what are the zeros going to be? Well, there's 3 of them. One is at 0, one is at minus 1, and one is at 1. And sign analysis is a very important topic that you discussed in Math 119 as well. What are you going to do? Plug it in. And I want to point out what you're plugging in. You're analyzing the sign of the factored form of that polynomial. So, for example, if you took a number to the right of 1, that would be like maybe 10 or so. It would be positive everywhere. Now, I know it's tough, but a number between 0 and 1, like 0.5, you're going to get a negative number if you plug it in. Again, this is not teaching. We're just reviewing what you've done in the past. Now, if I do a number between minus 1 and 0, like minus 1/2, I would get a positive number. Again, I want to point out to you, we're plugging it in the factored form of the polynomial. Now, let's keep going. Let me do like minus 2, plug it in. You get negative times a negative times a negative. Well, that's going to be a negative. What's your question? Where's it positive? I'm going to shade it in for you. It's positive here, and it's positive on this interval over here. What does that look like? Minus 1 to 0, union 1 to infinity. And that's listed right over here for you as an answer. And we give you an answer key for a reason. We want you to look at it. Now, graphing it, yeah, it might be a little difficult, but this is something you did in Math 119. Now, when I do this, I want to point out when I'm graphing it, my graph is not going to look as good as a machine, but I want to point down and put a really sloppy looking graph down. And I got 3 zeros, one at 0, one at minus 1, and one at 1. And I know the signs of it. And what's the sign going to be? It's positive over here, it's negative over here, it's positive over here, and it's negative over there. And I just do an odd function, by the way. It looks odd to me, all right? And again, that's the material you learned in Math 119. Again, this machine does that. And I want to point out that you probably should be learning how to use a machine as well. And, throughout my notes, I talk about machine use to get the graphs. I'm using a machine application to actually graph that out. This one, number 26, says solve it. How am I going to solve that? I guess I'm going to solve it by knowing something about logs. And what do you go over here? These are natural logs. I'm sorry, it looks like a limit, doesn't it? I don't want that to look like a limit. It's a natural log, and that means base A. And what do you get over here? 7x squared plus 4 over x cubed. All right, I got that part. And that equals a natural log of 4. Now, what do I know about this thing? They're both natural logs. Their arguments have to be equal. So 7x squared plus 4 over x cubed is equal to the number 4. Wow, this looks like a tough one, doesn't it? But I want to be honest with you, there's no such thing as a tough problem. So let's write this down. Oh, by the way, this is Math 119 now. All right? Let's write this down. 7x squared plus 4 equals 4x cubed. Now, this is a polynomial now, and I'm hopeful that I can solve it. So, by the way, there's a footnote over here. And I'm going to read that to you. I often put footnotes in my notes. It says rational root theorem may prove helpful. And the rational root theorem, it really was introduced at a very low level, like in Math 086, but they did not mention as rational root theorem, but it's certainly formally discussed in Math 119. So I'm going to write this as 0 equals 4x cubed minus 7x squared plus 4. And what I would do rational root theorem is I would probably look for some easy rational roots that would do it for me. And it's tough, though. I realize that people say, I can't check. But the possible rational roots, I'm not going to list them all. One would be the factors of 4 divided by the factors of 4. Well, that couldn't get any easier. I mean, it could be 1. It could be 2. And by the way, I could keep going on with this. But the bottom line is I don't want to keep going. I want to start seeing if one's going to work. So I'm going to say if you tried 1, that'll be 4 minus 7 plus 4. That's not going to work. If you tried minus 1, that's not going to work. So I'm going to move on to 2. I'm going to see if 2 works. And I put this down. So 4 times 8, I'm trying 2. If 2 doesn't work, I'm going to get a minus 2. And then what do you get? You're going to get 7 times 4, I'm trying 2, plus 4. So what do you get? 32. Did I do that right? 4 times 8, 32. 7 times 4 is 28. Plus 4. Ooh, I just made a mistake and I just realized it. Sorry about that. This is not 4, it's minus 4. Sorry, made a mistake. By the way, let me go back to the 2. And someone says, how'd you know you made a mistake? I kind of looked at it and I saw this. And then I didn't see that on that side because I'm subtracting 4 from both sides. I just spotted it. Let me go back to my 2. And what are you going to get? And see if it works out. And this is a question. I don't know. Maybe it doesn't. What do you get? 4 and 2 cubed would be 8. Minus 7 times, whoops, that doesn't look right. Minus 7 times 4, minus 4. Well, it's going to be 32. Again, it's a question. I don't know if it's going to work out. Minus 28 minus 4. What does this give me? 32 minus 32, which is 0. It does work out. So now I know there's a factor. And let me write this down for you. And I'm going to write it down for you. 0. I know the factor is 2. I'm sorry. I know the root is 2, so the factor is x minus 2. Here comes my trouble. I got to do a long division. But the long division will go really smoothly. X minus 2, and you learned this in Math 119. By the way, long division was taught to you in Math 100 and below. How would I do that? 4x squared. And what do you get? 4x cubed minus 8x squared. What would that give me? That would give me x squared minus 4. And then I'm going to say x plus x. That would give me x squared minus 2x. I got to subtract. That's 2x minus 4. Yeah, it's a lot of work, isn't it? And then what do you get? Looks like plus 2 now. So I'm going to say 4x squared plus x plus 2. All right? So I got a root. I know it's 2. And so I lost track of what you're doing over here because it's really, really tough, by the way. But, I'm going to say it's, most real problems are tough. They're not easy. I mean, if they're easy, everyone would be doing the problems. Like, everyone would be Mr. Tesla if all problems were easy. And I want to emphasize that most real world problems are not easy. All right? So what I'm going to do is I'm going to start to erase my work because I really have to proceed forward. And I want to see if I got a right answer. Let me erase this business over here. Erase this over here. And I want to look at the other factor I got. And I want to see if I can do that. I'm going to use the quadratic formula for that over here. So I want to point out what we're doing. I'm looking at this factor here. And I want to see if I can factor it by using the quadratic formula. So x equals, I'll write this over here for you, minus b, which is minus 1, plus or minus. It's a nightmare. I realize that. Let's see, b squared, which is 1, minus 4, times a, which is 4, times c, which is 2. Well, right now, I'm not going to proceed forward. And why is that? These are complex roots. So this has no real solution here. No real solution to it. So I only have one answer to check now. And I want to point out the answer I have to check over here. The answer I have to check over here is only one answer. I have to check this. Now, someone says I'm exhausted. I can't check it. Of course you can check it. I want to check it for you over here. So I'm going to check to see if x equals 2 is an answer. Well, let's write this down. What do you get? The natural log. Well, if I put a 2 in, what would you get? You get 4 times 7 is 28. 28 plus 4 is 32. Minus 3 natural log of 2. And they said that's equal to the natural log of 4. Well, right now, everything looks really good as far as numbers. I just can't compute those numbers in my head. But what I can do is I can rewrite these logs to see if it's true. And this would be the natural log of 2 cubed, which is 8. And they say it's natural log of 4. Well, things are looking much, much better now. I'll tell you why. I can write this as natural log of 32 divided by 8, and that certainly does equal the natural log of 4. So x equals 2 checks out beautifully. It really does. All right, let's look at this one over here. Verify the identity. These are much more difficult problems. There's just no doubt about it. Verifying an identity. What do? You have to pick a side. Right? I don't know what side to pick. I don't think I'd pick the absolute value side, by the way. It just looks too difficult for me. So someone says, let's try this side then. Let's see what to do with that. And I'll tell you what we need to do with that. We need to rewrite it. So I'll write this one over here. I'm choosing this side, and I'm going to make some attempt to rewrite it. So 1 plus sine x, 1 minus sine x. And I'm going to multiply top and bottom by the bottom's conjugate, which is 1 plus sine x. And 1 plus sine x has to be multiplied on top, by the way. What are you going to get over here? Well, you're going to get 1 plus sine x squared on top. This is the square root of it. What do you get on bottom? You would get 1 minus sine squared x. Well, you know what? That bottom looks familiar to me. I think I've seen that before. And what's that going to be? That's just cosine. So I'm just kind of moving along one step at a time. And I'm hoping at the end of this thing, I'll be staring at this. Let's write this down now. What do you get in top? You get 1 plus sine x quantity squared. And on bottom, what do you get? You get the cosine squared. Now, I'm going to point out that this is really simple to do, but you should realize the square root of cosine squared is not cosine. It's the absolute value of the cosine. All right, I got that part covered. Now, the top's a little bit easier, by the way. I'll tell you why. 1 plus sine x is never going to be a negative number. So the square root of that thing over there is just simply 1 plus sine x. Are we getting what they said we're getting? Certainly. What did your Math 120 teachers tell you to write down at this point? QED, which is Latin for we did what we were asked to do. All right, this one is a composition. Compositions can be difficult. They're asking for domain, but it appears they're not asking for a domain over here. I want to point out f of g of x. What does it stand for? F of g of x. What's g of x? Well, let's write this down. It's 2x minus 3. What does f do to that? It squares it. It adds twice that. And then it subtracts 1. What do you get over here? 4x squared. I'm simplifying. That's going to be minus what? Minus 12x, right? Plus 9. Then what are you going to get? Plus 4x minus 6 minus 1. I'm going to add all that together. That's 4x squared minus 8x. Let's see. 9 minus 6 is 3, and 3 minus 1 is 2. Got that over there. Not bad. All right. Let's do this one over here. Not that bad. So it's g of f of x. So someone says, I wonder what that does. Well, let's write this down. It's g of f of x. What's f of x? I'm not memorizing. I'm just reading. It's g of x squared plus 2x minus 1. What does g do to that? It multiplies it by 2. And then what does it do? It subtracts 3 away from it. Let me do the algebra. That's 2x squared plus 4x minus 2 minus 3. And if there's anything you could do that's simple, you want to do it. That's minus 5. I'm seeing that right over here. All right? By the way, you can read my footnotes if you want. There's not, ooh, this one looks crazy. What does it say? It says g of g of g of x. A lot of students have a tough time matching parentheses, by the way. And if you do, you want to concentrate on that, all right? So the number of left-hand parentheses should equal the number of right-hand parentheses. I'm seeing 3 and I'm seeing 3. Let's write this down. And I know it's tough. I'm not saying it's easy for students to do that. All right, what's g of x? Well, I can't remember. I'm going to write it over here. It's 2x minus 3. Let me write that down. G of x is 2x minus 3. Let's keep going. What do you get over here? Well, I'm going to do this thing on the inside now. What does g do to the argument? It doubles it, which would be 4x minus 6, and then it takes 3 away from it. Well, let me write that down for you. That's going to be g of 4x minus 9. What does g do to that argument? It doubles it, which would be 8x minus 18, and it subtracts 3 away from it. What does this give me? 8x. Well, minus 18 minus 3 is minus 21. Relatively simple. All right? All right, this one's a, by the way, this is math 119. Let me make sure I wrote that down for you. Math 119. This is math, whoops, don't go too fast. This is math 120. At Essex County College, by the way. And so I got that covered. Let me keep going. Again, I know it's tedious. I want to point out, you really want to select a major that's not tedious for you, that you actually enjoy doing this. And sort of, even though I've been doing this for a long time, it's kind of soothing to do the problems. It really is. All right. If you're finding it to be something you don't want to do, like, like I don't want to wash windows, for example, I'd find it a very tedious activity. Some people love doing it. I don't like doing it. So let's take a look at it. And what do they want me to do? Write the first 5 terms down, starting with A1. Well, I can do that. What's A1? Well, that's where n is 1, so it's 1 times 2 to the first power. What do you get over there? 2. I see that. Let's put down A2. What does that give me? 2 times 2 squared. Well, that's pretty simple. That's just simply 2 cubed, which is 8. I'm seeing that right over here. Let's put down A3. And there's a very simple pattern to this over here. What's it going to be? 3 times 2 cubed. What do you get over there? 3 times 8, which is 24. I see that over there. Let's put A4 down. Yep. 4 times 2 to the 4th power. Whoa, that's 2 to the 6th power. 2 times 2 is 4, times 2 is 8, times 2 is 16, 32, 64. Yep, you expect to be able to do arithmetic. What's A5? Geez, that's 5 times 2 to the 5th power. Well, that's 5, and 2 to the 5th power is 32, and 5 times 32 is 150 and 10, which is 160. I'm seeing everything. Now it says, is the sequence arithmetic, geometric, or neither? You should know that it's not arithmetic. We're not adding on a constant. Now, is it geometric? Well, it's not a common ratio between those terms, so it's not that. So I'm going to say neither. Okay? All right, this one over here, again, a little more complicated. And it's, by the way, this one over here is math 120. All right? This is math 120. All right, let's write this down. And this is arc cosine. And I got to do the cosine of 7 pi over 2. Now, someone says, I wonder what 7 pi over 2 is. Now, again, when you first did trigonometry, your teachers might have said the wheels on the bus go round and round. That's 1 pi over 2, 2 of them, 3 of them, 4 of them, 5 of them, 6 of them, 7 of them. So I'm over here. Now, someone says, do you need to go there? Yeah, I need to go there. I need to figure out what this value is. So someone says, what's the cosine of that angle? The cosine of this angle. And I'm going to call it theta, by the way. And we're at this point over here. Well, I hope you realize this is going to be defined as the x-coordinate. This is the x, or the abscissa, over the ordinate, which is, the ordinate's the y, but over r, which is the radius of this thing over here. And I got to be honest with you, it doesn't matter what the radius is. X is going to be 0 there. It's just going to be 0. Now, someone says I'm still not done with it. I'm going to erase my little baby picture. I don't need that anymore. I know that number's 0. So then the next one, oh, sorry, I didn't mean to erase that part. That was math 120. So when I do this over here, I draw pictures, and you may not. You may say, no, my teacher made me memorize these things. Whatever works. It's right over there. What's that going to be? Pi over 2. All right, this one perform the indicated operation. Just couldn't get any easier. It's 1 minus sine x, common denominator, 1 plus sine x. And what do you get on top? 1 plus sine x. Couldn't be easier because it's an addition problem, 1 minus sine x. And what do you get over there? Well, on top you just get 2. On bottom you get 1 minus sine squared. And I recognize that. What's that going to be? That's going to be 2 over cosine squared of x. And I can write that a little bit simpler, by the way. That's going to be 2 secant squared x. I'm going to say it's the simplest form I could write down. What do they got? Answers are looking at it right over here. All right, this one's going to require a calculator. If I want to point out calculators are not allowed in exams, so I'm just going to, maybe draw a picture for you and write down what the computation is, and then simply say you can use the calculator, but just not on exams. You leave the answers in what's called closed form. So it says when an airplane leaves the runway, it climbs at an angle of 19 degrees. This is the runway, and it leaves at an angle of 19 degrees. Its speed is 300 feet per second. All right. Now, by the way, I want to point out, the speed of the plane is its speed through the air. So the speed is going to be the hypotenuse of the problem, and it's 300 feet per second. But I have to get a distance out of this guy. And over here it says, find the plane's altitude after 30 seconds. So I'm going to say this is going to be a distance now. It's rate times time. And what would that give you? That would give you 9,000 feet. I'm going to start to erase things because I'm kind of done with this over here. I was going to put down 9,000 feet. And what's your question? What's its altitude? I don't know. I'll put down A. So what do I do over there? I'd probably use sine. So sine of 19 degrees would equal A over 9,000. I could definitely write the answer down. So the altitude is going to be equal to 9,000 times the sine of 19 degrees. Now again, someone says, I wonder what the units in that. That's going to be in feet. If this is an exam question in a Math 120 class, this is Math 120, that's the answer you'd list. Now, if you're using a calculator, which we recommend you learn how to use, you would approximate this and say approximately 2,930 feet. Now, someone says, how would you do it on a calculator? If you have trouble using your calculator, come by during office hours, and I'll be more than happy to show you how to use your calculator, including if it's your cell phone. All right? So this one over here says, which are decreasing for all x. And I got to be honest with you, looking at them, you might have a tough time with this one over here. So the one thing I kind of know right off the hand is this thing's a wave problem. So that's not always decreasing, all right? Now the log function looks like this over here, and that's an increasing function. So this one's no good, all right? Now I'm looking at the cube root function, taking away 2 from it. What's the cube root function? It sort of looks like this over here, and that's an increasing function, so this one's no good. Now what does e to the minus x look like? By the way, this is Math 119 now. What does e to the x look like? It looks like this, and that's a decreasing function. So only this one decreases, and that's written over here for you. Describing the following set as an interval. Boy, that looks really strange to me. But here's the deal. It's read as x such that x divided by x plus 5 is less than 0. Well, I think I can do it, and I'll point out what I mean by that. We're basically solving a very simple rational inequality. Where was this covered? In Math 119. And I'll write this down for you. Number line goes down. The zeros get listed. The 0 of the top polynomial is 0, and the 0 of the bottom polynomial is minus 5. And this is where those things change their sign. So I'm looking at it, and I'm going to take a number after 0, like 1. If you plug it in, it'll always be positive. If I took a number between minus 5 and 0, like minus 1, and plugged it in, it would be a negative. I'm looking at this over here. And if I took a number below minus 5, like minus 6, the top would be negative, the bottom would be negative, and the ratio is positive. Now what do I want? I want it to be negative. And where's it negative? Between minus 5 and 0. And that's listed right over here for me. All right, let's go to 35. 35 is complex numbers. This is covered in Math 120. All right. So it says, z equals -1 minus I, find a trigonometric form, and it also requires you to remember a theorem, de Moivre's theorem. A lot of times you can't remember things, and that's fine, by the way. A lot of things I can't remember either. I got to look them up. There's nothing wrong with looking things up. You might have to look that up. So de Moivre's theorem, you might have to look up. You may not be able to remember it. But I'm kind of looking at this, and I hope your teachers, when you took Math 120, helped you visualize these things. This is the real axis, and this over here is the imaginary. And by visualizing that, I'm noticing it's -1 along the real and -1 along this over here. And I got this thing over here, and I'm going to say this is what the complex number is. Now, this is the reason it's taught in trigonometry, because it's really easy to do the trig on it. And that's why we put it in trigonometric form. What's the angle over there? Well, looking at it, it's between 180 and 270. What's the reference? It's 45 degrees. So 180 plus 45 degrees is 225 degrees. All right? So I know the angle. All right? Now, what's the other part of it? I got to get this, the radius down for this. And what's the radius over here? Well, it's a 45, 45, 90 reference triangle, so it's just a √2. All right? So how do I write this down? Z is going to be that radius number, which is √r. That's often called the modulus in math. And the other thing is called the argument. The angle is the argument. And it's written as cosine 225 degrees plus I sine 225 degrees. And this is a complex form. This is a trigonometric form of the complex number -1 minus I. You could also write down what's in radian measure, which we would prefer to see. And what's that going to be? That'll be 5 pi over 4. I want to point out, this thing is written so often that some people abbreviate it CIS. And what does it stand for? Cosine plus I sine. What angle is it? It's 225 degrees. Let me go back to 225 degrees. This is the same thing as 5 pi over 4. And you should be able to do that quickly. What else they ask for? They want, Z9. Boy, that's a tough one. How do you do that, though? It's fairly simple to do. So Z9, this is de Moivre's theorem. You're going to raise the √2 to the 9th power times CIS, and then it's going to be 9 times 225 degrees. All right? So I'm going to say that's what it is, but they want to put it in standard form. And that's tough. Now, why is it tough? I got to figure this out. And I'll tell you what it is. 9 times 5 pi over 4, which is going to be what? 9 times 5 is 45 pi over 4. I'm going to write this a little bit differently, by the way. I want to get 360 out of this guy. I want to see how many times I got to be rotating this thing around over here. Let me see if I can do that. That's a big number, isn't it? So 45 times pi over 4. And I'm going to just see if I can do that. And I'm going to just kind of march along. So each time I go around, that's going to be 8 of those things, right? I hope I don't make you dizzy doing this. 16. Well, eventually I get to 32 of them, right? Some multiples of 8. Now, someone says, why are you doing 8? 45, times 8 of those things would be 2 pi, right? So let's think about that. We got 45, right? I'm looking to get an 8 out of that. And I'm going to erase this over here. I'm thinking it's got to be something to do with 8, right? So 8 times what gets close to 45? That would be 5. Let me write this down. 45. Is going to be 8 times 5 plus 5. So someone says, why do you do it that way? You don't have to. You could count it if you want. There's nothing wrong with that. But I think that's pretty easy to think about it now. What do I got? I got 8 times around, and then I got to do 5 of those things, right? And what's 5 of those things worth? I'll write that down for you. Let's see. 1, 2, 3, 4, 5. Wow, I'm back at the beginning. And someone says, what do you mean you're back at the beginning? I'm back at the beginning. And the beginning is the beginning. It's the same thing. And what's it going to be? Well, this thing over here is going to be what we said it's going to be, minus 1 minus I. I got this part over here. And then, I'm looking at this thing and, oh, this is going to be tough though, isn't it? And I got to figure out the radius of that guy is. And that would be root 2, isn't it? I'll put that down over here. I got that part down. And I got this thing over here, which is root 2 to the 9th. And that's going to be, whoa, that's root 2 to the 10th. And that's going to be 2 to the 5th. And what's 2 to the 5th? 2 times 2 is 4, 8, 16, 32. I think I might have made a mistake somewhere. Let me take a look at this. Let's see, 9. Yeah, I think I made a mistake somewhere. I'm going to go backwards. I hate to do that to you. Let me just erase this over here. I got to be really careful what I said, by the way. Let me go step by step, all right? So let's put this down. So z to the 9th. And what do you get over here? Oh, I think I know I made a mistake. And let's put this down over here. So what do you get? Let's see, root 2 to the 8th power, 2 to the 4th is 16 root 2. And now I got to do something. I spoke too quickly on it, and I realized that. And this is going to be, I think there's a mistake in my key too, by the way. And I got to do yeah, I really screwed up. But anyway, I'm going to go back to it. I want to point out what I'm doing over here. I'm doing this over here now. And what's that going to be? We just did it, right? And I'm going to say it's going to be, what is it going to be? Oh, now I know what I did. I know I made a mistake here. I actually didn't compute the number. What's going to be cosine of that number, which is going to be minus, sorry about that. It's going to be minus, I keep doing it. It's going to be minus 1 over root 2. Minus I, and that's a mistake I made. I wasn't even thinking. And that's a really bad thing to be doing. And what does that give you? There's no mistake in the key. Z9 is going to be equal to minus 16 minus 16I. Yep, no mistake in the key. All right, that's DeMoss theorem, by the way. Math 120. Okay? What I'm going to do now is I'm going to take a break, and I'll come back and finish it up.